Good day everyone. I'm going to discuss the last theory of chapter 7 from 7.6 applications, which is about writing equations. And well, explaining this theory, the book gives you a very practical example of something that can occur in the exercises after theory B. So I'm going to explain it using this example as well. They start by giving you an exercise, right? There is a path of uniform width, which means it's the same width everywhere, around a swimming pool measuring 6 by 8 meters. The area of the path is 32 square meters, right? So the area of the path, not of the bath itself. You can calculate the width of the path by solving a quadratic equation. Call the width of the path x meters. If you get something you have to calculate, like for example the width of a path, it's often very nice to call that thing x. What I'm searching for is called x. That what is unknown I will call x. Okay. Now you can divide this path that surrounds the swimming pool in different pieces. You have the corner pieces that are red, you have 4 of them. You have the 2 green pieces. And last but not least, we have the yellow pieces. Can I now say what the area is of every colored piece? Yes, you can. Not in numbers, but you can use a combination of numbers and letters. Because, for example, this red corner piece here, its width is x and its length is x as well. So you can now say, well, the area of a red piece is x times x is x squared. Well, what's the area of a green or a yellow piece? Take a look if you can figure this out by yourself. Well, I think that the width is always x, and then the length, you could say, for the green piece is 6 times x, and for the yellow piece it's 8 times x. But you shouldn't forget that the red pieces occur 4 times, and the green and the yellow pieces both occur 2 times. So what I could now say is, well, if I add up all those pieces together, they should form an area of 32 square meters, right? So that's what they're doing right here. They say 4 times x squared, because I have the red piece 4 times, plus 2 times 6x, that's the green parts, plus 2 times 8x, gives me 4x squared plus 12x plus 16x, or you could say 4x plus 28x, is equal to that 32 square meters. And that's how you form an equation out of this. And now I can solve for x, and if I solve for x, I know the width of my path, because that's what I called x. Call the width of the path x meters. So from here on out, we're going to solve this using the methods that we've learned through this chapter. First, we make the right hand side 0, and here you first have to divide all the terms by 4, right? So you get x squared plus 7x minus 8 equals 0. Which method are we going to use here? Well, I think the only one that we can use is the product sum method. So I search 2 numbers which together are 7 and multiplied are minus 8. I think that's 8 and minus 1, right? So now we've factorized, and using the rule 8 times b equals 0, I can now say x plus 8 is 0, or x minus 1 is 0. So using the balance methods, minus 8 on both sides gives me x is minus 8, or plus 1 on both sides, x is 1. So the width of the path is either minus 8 meters or 1 meter. Which one do you think is most likely to occur? Well, hopefully you will say that the width is 1 meter, right? You cannot have a path that has a negative dimension. So you cannot say it's minus 8 meters. So you sometimes have to check whether an answer that you get out of solving an equation is also applicable in this situation. Here, minus 8 meters is not possible. So the only possible solution here is x is 1. Therefore, the width is 1 meter. And you will see at the exercises that follow theory B, you have to find out or make your own equations. And that can sometimes be, well, I wouldn't say exactly difficult, but you have to think a bit differently than you're used to this chapter. Remember that oftentimes you have to divide things up in multiple pieces and then add them up later, because you cannot say what the area of the pot is in total, but you can say what it will be if we add up only the parts. Okay, good luck. If you want to, I've also uploaded a video about an exercise after theory B. Watch that one if you find this difficult, and again, I wish you good luck.